DNS records, and you create a DNS ticket, right? So a DNS record is going to point your abccactus.com to this host name. So a DNS record like this, it's called a CNAME record, and all it does is it, tells you if you're going to abccactus.com, if you type abccactus.com into your browser, it's actually taking you there, and then that is going to take you to a specific IP address, right? So that's all a domain DNS record is. So, but there is a slight caveat here. There are also, so there's two types of DNS records that we want to talk about. There's CNAME records, which point host names to host names. So a CNAME record would be abccactus.com, pointing to abc-cactus.azurewebsites.net. That's a CNAME record, stands for canonical name. The A record points to an IP address. Same exact deal, except it's specifically pointing to an IP address. So in this example, I've got kind of two kind of example records. We've got abc.cactus.com pointing to the Azure websites. That's a CNAME record. And then there's an A record in this example where abc.cactus.com is pointing to the IP address 1234, okay? So these are two types of DNS records. If you look at subdomain takeovers and you do research online, you'll probably see that most people talk about CNAME records when it comes to subdomain takeover. I don't see a lot of talk about A records, but it can happen with A records, and we'll get more into that later. Anyways, in this scenario, everything's great right now. There's no vulnerability. The website's up, everything looks good. The problem is when we decide to decommission this resource, okay? So we're gonna tear down this resource in the cloud, and it's gonna go away. It's not gonna be there anymore. But the DNS record still exists, okay? That's the ultimate vulnerability. So there is a DNS record that's pointing abc.cactus.com to the host name abccactus.azurewebsites.net, and there's nothing there. There's nothing at that location. So if you tried to go to abc.cactus.com, it's not going to work. You're going to get whatever error message you might get depending on your cloud provider. But an attacker could create a resource in the cloud at this point, whether it's Azure, AWS, and they can call it abccactus.azurewebsites.net. Now they have taken over your subdomain. So if you go up on your browser and you go to abc.cactus.com and you hit enter, you're actually going to end up on a site that's controlled by an attacker. Okay, that's the vulnerability. That's the issue. So what are the risks there? So at a minimum, you've got an excellent fishing spot. So grab your tackle box and your fishing pole and camp out at this location. So you can create a fake login page. So you'll see the browser actually shows abc.cactus.com. So it looks legit. It looks real. User might type in their credentials, but it's actually an attacker-controlled site, and they could be harvesting those credentials or whatever. So that's one risk off the bat. The next risk is defacement or reputation issues. So in this example, if you protect your brand very closely, you may not want a website with your company name and the URL that looks very legitimate to say something that wouldn't look so great for your reputation. So the last one is serving malware. So if you've got a site, maybe your company specifically has software that their customers download, a user might trust abc.cactus.com as a link. If they get an email, all of your phishing campaigns to teach people what links not to click, all of it's out the window. This link looks fantastic. Why wouldn't they click it? It says abc.cactus.com. So you can kind of bypass some of your phishing campaign knowledge there. Okay, so let's talk about the other two vulnerabilities that you might have risk. So if you're looking up subdomain takeovers, you'll hear that you might be able to have your cookies stolen. If users visit this site, it might send the cookies to that site. It's not always true. It really depends on the configuration. And you might also read that cross-site scripting might be more possible. And that's also true, but it really depends on your configuration. So I'm actually going to jump into these two, and we're going to talk a little bit about what makes that configuration, what opens you up to these risks from a subdomain takeover perspective. So as far as stealing cookies go, by default, if any of you are familiar with the same origin policy, or SOP, you are by default protected. www.cactus.com isn't going to send cookies to abc.cactus.com by default. So the hacker's server isn't going to get any of your user cookies. But you can override that default behavior, and that's by when you set your cookie using the domain attribute on your set cookie header. Okay, so in this example, if we had a cookie that was set, maybe it was set by www.cactus.com, and it was given an attribute of domain equals cactus.com, the cookie will be sent to abc.cactus.com, okay, because it's a subdomain of that attribute. So in this example table that I have here, you'll see if it's cactus.com, it will be sent to abc.cactus.com. If it's www.cactus.com, it will not be sent because it's not a subdomain of what's abc.cactus.com is not a subdomain of www.cactus.com, okay? So the only thing that I could see that would cause you to send cookies to a separate, domain, even if it's one that looks like you own it, is this cookie flag. It might be possible in certain SSO configurations that use cookies and the domain flag that this could present an issue. So in the context of SSO, this might be a problem. So, okay, and then the next one is cross-site scripting. So I have a little example here, a couple examples of how cross-site scripting might become more possible if a subdomain was taken over. So in this example, we've got a pretty basic website. It's flush with lots of content, as you can see. But one of the things that it does is it imports a script. So let's remember where we are. We're on www.cactus.com. And it imports a script from abc.cactus.com. And in this scenario, our hacker took over abc.cactus.com, right? So that subdomain now belongs to the hacker. Whatever's there belongs to the hacker. So the hacker could simply create a script called script.js, and anytime someone loads your site, that script's going to run. So in this scenario, you've essentially allowed an attacker to take over a subdomain that one of your other sites imports scripts from. I don't think this is quite as likely because at some point, in order for the hacker to have taken over that subdomain, you had to decommission that resource. So if that script does anything, your site probably broke for a little while while you were vulnerable to subdomain takeovers, and then you didn't notice it, I guess, and then a hacker took it over, and now they could squeeze some XSS by. So that's one way. There's another way I want to talk about, and it's very similar, but it has to do with everyone's favorite security header called the content security policy. So here's a quick example of the content security policy header. So if a site like www.cactus.com is using this content security policy, you can see that it is allowing scripts to come from abc.cactus.com. So while this header may have been protecting you from XSS before that subdomain was taken over, there's now a way through this header, essentially. There's a hole in your security, and if the attacker took over abc.cactus.com, any scripts that they host could get past this header, whereas they couldn't before. So if you are a hacker, if you're a bug bounty researcher, the content security policy might give you a decent place to look for juicy subdomains that you could take over. Again, it's likely that your site probably broke at some point before you became vulnerable, so I don't think these XSS scenarios were quite as likely to occur. You would have had to have JavaScript being imported that wouldn't have been noticed if it wasn't there anymore. The server that was hosting it went away, but it can happen. So this is another risk. So that's the XSS risk and the cookies risk, okay? So enough about the risks. So they're pretty dangerous. Let's talk about getting rid of them. So ultimately, it's a DNS hygiene issue. That's where the vulnerability is. It's not in the application code. It's in your DNS records. So you need to find all the DNS records that point to cloud resources that you no longer own, and remove those DNS records, or in the words of Mr. Smith, find them and destroy them. So here's an example of a DNS records, your DNS records. So in this example, we've got two sites on the bottom that are ABC Cactus. So those are the middle entry that points to abccactus.azurewebsites.net. That would be like a CNAME record. And the one at the bottom would be like an A record. And because our hacker has taken those over, or because they're vulnerable to subdomains, we need to delete those records, right? Those need to go because they're opening you up to subdomain takeover. The challenge is finding those records. So gather all the DNS records that point to a cloud resource. How easy is that to do? Figuring out if the content of your DNS record happens to be something that you have hosted in the cloud or not could be rather challenging. Determining if the resource still exists is also maybe not so easy. How do you know for sure that there's nothing there? And then deleting the DNS record. So fortunately, there's a really awesome tool that we actually use called DNS Reaper. You can feed it your DNS records using an API token for your DNS provider or by feeding it a list. And it will actually it'll find all the records that are pointing to a cloud resource, and it'll compare the response that it gets with, it's an open source community, it's kept up to date, so they've basically fingerprinted like what common cloud provider responses are when there's nothing that's really hosted there. So I've used this for a few months now in my automation, and I haven't had any false positives so far. So it works fairly well. So caveat with it though is it only is detecting CNAME records. I spun it up. It was great, it was working, we fixed a bunch of records, and then I got a subdomain takeover through the bug bounty program, and I was like, what? I thought I was checking for these. They were A record submissions, so now I had to solve that problem. So how did I solve that problem? Well, I wrote some automation, and I want to give you an example of what that automation could look like in case you are interested in implementing that automation. I also have a working script that does exactly this, okay? So the first thing that you'll want to do is find all the IP records that point to a cloud IP address, right? So these are A records, so they're IP addresses. Now, I found these two really awesome sites. The first one's actually like more of an API endpoint. The second one gives you back a JSON, but it shows the Azure and AWS IPs, so you can kind of take your DNS record IP addresses and check them and see if they are in the cloud. And then you want to find all the public IP addresses in your cloud environment. I provided an Azure example because that's what I'm most familiar with, so you can use the resource graph query with a query like this one, and it will return all of the IP addresses and the subscriptions they came from. There's a little bit of a challenge, maybe making sure that your request has enough access to actually get all of the IP addresses, but once you overcome that hurdle, you'll have a list of all the IP addresses of your cloud resources. Now you just need to check the two, right? So remove any records that are pointing to cloud IPs that are not in your cloud IP list, because they're clearly not yours anymore. Okay, so let's just walk through that really quick. So if we have a DNS record, we've got all these A records on the left, and we've got our cloud environment on the right. These are all the IP addresses in our Azure or AWS or GCP environment. We're just going to iterate through all these IP addresses and check and see if they are in the cloud. We discovered that these two do not point to the cloud, and maybe they point to like an on-prem server or something. But these two, the rest of them do point to the cloud, and these two exist in our cloud environment. We found them. So that means they're good to go. We don't have to delete them. But what about the one that was left over? So this record is pointing to the cloud, but not to anything we own. Okay, so that's how we've detected this dangling DNS record, or this vulnerable subdomain takeover. And so that's essentially what my automation is doing. So this is what I run every morning at 8 a.m. I run DNS Reaper with an API token. It runs the CNAME scan and saves the results to a JSON file. I then run my custom A record script, which again, you can find on my GitHub. I'll have a link. And it is using Cloudflare and Azure. So it downloads the DNS records from Cloudflare, and it uses some Azure credentials to do the checks I mentioned on the previous slide. We append the results to the JSON file, and then I have a Slack message that looks just like this one that hits every morning when my automation runs, and lets us know if there are any records we should check out. So whenever I get a hit, 9 times out of 10, the previous day, they decommissioned a bunch of stuff, and they didn't clean up the DNS records, right? And that is ultimately what the issue is. So I listed some tools here that you might want to use. So the first 3 tools are more for your AppSec, application security team. The first one is just my script. So this one scans specifically A records, and it's written in Python. You can check it out. The second one is the DNS Reaper. It's also written in Python. That's the one I mentioned before. Azure or Microsoft does provide a get dangling DNS records if you're a PowerShell person. And then the last 4 are actually more for your bug bounty hackers. So if you're on bug bounty and you're like, ooh, 22%, that's tasty. I want to get in on some of that action. Then you might want to check out these tools. They'll help you find DNS. They'll help you find some of your DNS records from a black box more scenario, right? If you're on an AppSec team, don't use these. Just go get your DNS records straight from your provider. No need to try to guess what they are. Okay, so that's how we detect and automate. Here's a couple other solutions. The first one is what we were using before I automated our checks. That's a bug bounty program. So you're paying out of pocket for those every time they find one. You can scope a pen test. You can use a tool like ThreatNG's Subdomain Takeovers, or Prisma from Palo Alto Networks also does Subdomain Takeovers. So if you're already using these tools, maybe ask about Subdomain Takeovers. And then there's a company called Detectify that does this as well. They actually did a study, and between 2020 and 2021, they saw a 25% increase in Subdomain Takeovers as a vulnerability, and that was 3 years ago. So with all of our cloud dependencies, that could be going up a little higher. Okay, so let's just talk real quick about preventing it from happening in the first place. I think it's quite obvious. Your DNS records are the issue, so improve your decommission process. DNS records should go down first, and then the resource that it's pointing to. This is usually just skipped, right? We forget to delete DNS records. But there's 2 things you can also do to reduce the risk, and one of the ones I want to talk about really quick is called a CAA DNS certificate. So this, you'd create this certificate with your DNS provider, and they would not let any other, your certificate, they would not let anyone else create a certificate for your domain, right? No other company could do that. So what this protects you from is if somebody took over your subdomain, they couldn't use HTTPS on the site because they can't create a certificate for it because you have a CAA DNS certificate. So this will block people from creating certificates. So it'll make the site look a little less secure. So that might keep your users from actually entering any credentials or trusting the site. Maybe they'll try to go to www.cactus.com and figure out what was going on. And then lastly, that domain cookie. So that domain attribute on your cookies is what's going to allow that record to, or the token, whatever your cookie is, to be sent to any servers with a subdomain. So if you don't do those, then you'll be in good shape. All right, that's all I got. Any questions? Thank you.
We have a question on Discord. What was the thing you do every morning? They missed that part.
Yeah, that's my script that I run. So I run a script every morning. It actually kicks off all by itself. And it is both DNS Reaper, followed by my A Record scanning, which can be found at this GitHub link. There's a README to help you figure out how to set it up, because you do need some Azure credentials and some Cloudflare credentials. But yeah, this is what I'm doing every morning at 8 a.m. Is I'm running this script and DNS Reaper.
And then where the slides will be available?
Yeah, I can post the slides. I can maybe put a link to them on the Discord or something afterwards. Yeah, that works.
You can do that.
Cool.
Any other questions?
Yeah.
Great presentation.
Thank you. Yeah.
So I think over the last few years, like the automation for detecting and also remediating, right, has gotten a lot more advanced. I'm just curious from like your experience, the user education piece, right, is why we have this issue. And that's a challenge I know that company I work seems like we just continue to have
Yeah.
more and more.
Yeah. Okay. So the question was basically, how do we prevent these from happening through kind of user education? How do we make sure our IT teams or our developers aren't doing this to themselves? It's a great question. There's really a couple solutions. It kind of depends on how your organization is set up. If there's a chance if your DNS records are being created by your IT team, then there's probably some learning that you would be able to do with your IT team. Being able to detect it yourself and let them know every time it happens might get them to kind of say, why do we keep getting these tickets from the InfoSec team? Maybe we should stop doing it. I'll tell you that we invest in a security champions program, and so a security champion on various development teams and even on IT teams. And then we kind of educate those and do security training with those champions and hope that they spread the news. So that's probably what I would recommend. Yeah.
Awesome. And
actually came from in order to narrow down that location, or is that just something that's better done like man to man?
I'm not sure I'm understanding the question. Can you try one more time?
So if you have multiple layers of virtualization in your site,
Yeah.
have it set up where it's broken down into different layers. Is there any way to automate if you get hit, looking at each of those layers to see where the data came from?
There might be. The challenge is what I've talked about is detecting the vulnerable state. But your question is kind of like, if we've already had the subdomain taken over, how can we detect that? And that is a lot more challenging because, you can't check, is there nothing here, which is what DNS Reaper is kind of doing. It's saying, is there nothing hosted here? So at that point, you really do have to kind of go the route of looking at all of the publicly kind of exposed host names or IP addresses from your cloud environment and just comparing those to what you have in your DNS records. That's always going to tell you if you have any subdomain takeovers, or if you're vulnerable, or if there are any that are already taken over. Just looking at it's all about the DNS records. So cleaning that DNS record system out is going to be what helps you.
Might have to run a validation exercise.
Yeah, and that could be painful. Yeah, a validation exercise here could be very painful. It's not so easy to detect these types of things. It shocks me that Cloudflare or some of the more cloud providers don't already have some functionality. I suspect that as this becomes a more popular topic, they will develop some of that, but right now there really isn't anything out of the box that'll help you too much with this. Yeah.
Awesome.
I hope that answers your question.
You did.
Okay, cool.
Awesome.
Thank you, Anthony.